Now we are moving towards the civil engineering section. The first question is, a city generates 40 into 10 to the power 6 kg of municipal solid waste per year, out of which only 10% is recovered or recycled and the rest goes to landfill. The landfill has a single lift of 3 meter height and is compacted to a density of 550 kg per meter cube. If 80% of the landfill is assumed to be municipal solid waste, the landfill area in meters square up to 1 decimal place required would be. So the question involves only aptitude. There is not much technical concept here. It is given to us total generation of municipal solid waste is 40 into 10 to the power 6 kg. Now 10% is being recovered and the rest goes to landfill, which implies rest will be 90%. So 90% of this much, that is 0.9 into 40. So 36 into 10 to the power 6 kg of MSW goes into landfill. Now it is also given to us, if 80% of the landfill is assumed to be MSW, it implies that at the landfill the solid waste is not only MSW but also other waste, and other waste comprises 20%. So let the mass of solid at the landfill be M. So this M will be equal to MSW and the other solid, and it is given to us this is 80%. So if this is 80%, so it will be 0.8 M and this will be 0.2 M. Now it is given to us that MSW, that is 0.8 M, is this much. So this is 36 into 10 to the power 6 kg. So from here we can calculate mass of solid at the landfill will be 36 into 10 to the power 6 by 0.8 kg. So this is 45 into 10 to the power 6 kg. So if mass we have calculated, then we can solve for volume. Volume will be equal to mass by density. Mass is 45 into 10 to the power 6 kg and density given to us 550 kg per meter cube. So from here we get 9 by 110 into 10 to the power 6 meter cube, and we have to finally calculate the area. So area into depth, that is 3 meter, this will be equal to 9 by 11 into 10 to the power 5 meter cube. So area will be equal to this value add by 3, so it will be 3 by 11 into 10 to the power 5. So it comes out to be 2727 2.7. So this will be our answer. The next question is, a 10 meter wide rectangular channel carries a discharge of 20 meter cube per second under critical condition using G equal to 9.81 meter per second square. The specific energy in meter up to 2 decimal places is. Now we know that for wide rectangular channel, specific energy at critical condition is 1.5 into YC, that is depth at critical condition, and we also know that critical depth is given by Q square by G to the power 1 by 3 for wide rectangular channel. So here we can put YC will be E by 1.5. Small q is discharge per unit width. Total discharge is this and width is 10 meter. So small q will be equal to 20 by 10 whole square divided by g is 9.81 whole to the power 1 by 3. So from here we can calculate E will be equal to 1.5 into 20 by 10 to 2 square, so 4 by 9.81 to the power 1 by 3. So it comes out to be 1.112299. So up to 2 decimal places it will be 1.11. This will be our numerical answer. The next question is a 1:50 model of a spillway is to be tested in the laboratory. The discharge in the prototype spillway is 1000 meter cube per second. The corresponding discharge in meter cube per second up to 2 decimal places to be maintained in the model, neglecting variation in acceleration due to gravity is. Now first, for design of hydraulic structures, that is spillway or canal, the governing equation is Froude law. So we know that the Froude number is given by V by Gy. So Froude number for the spillway and its model will remain constant, which implies that we can say V, that is velocity, under root G, and Y is the depth and is represented by length. And since G is constant, this value is constant, it implies that V equal to K root G into root L. So if this value is constant, we can say V is equal to proportional to root L. Now since discharge is area into velocity, area will be proportional to L square and V is proportional to root L. So discharge is proportional to L to the power 2.5, which implies that Q of the model and the Q of prototype, their ratio will be equal to L of model to the L of prototype to the power 2.5. Now it is given to us that it is 1:50 model. This is the ratio of dimensions, that is length. So this by this is 150, and it is also given to us the discharge in the prototype is 1000 meter cube per second. So QP is 1000 and QM we have to find out. So QM will be equal to 1000 into 1 by 50 to the power 2.5, and it comes out to be 0.0565 meter cube per second, and we have to give answer up to 2 decimal places. So up to 2 decimal places it will be 0.06 meter cube per second. This will be our numerical answer. The next question is, there are 20,000 vehicles operating in a city with an average annual travel of 12,000 km per vehicle. The NOx emission rate is 2 gram per kilometer per vehicle. The total annual release of NOx will be. Now it is again an aptitude based question. There are 20,000 vehicles and each vehicle has 12,000 km travel time. So NOx emission will be equal to 2 gram per kilometer per vehicle multiplied by total number of vehicle is 20,000 numbers and travel length of each vehicle is 12,000 km. So from here we can directly calculate the mass in grams. So 2 into 20,000 into 12,000, 2 into 20,000 into 12,000. This will be the mass of NOx generated in grams, and in kilogram will be divided by 1000. So 2 into 20,000 into 12. So it comes out to be 1224 48,000. So the correct answer would be A option. The next question is, a bitumen sample has been graded as VG30 as per IS 73/2013. The 30 in the grade means that, now as per IS code, if it is VG30, then here V implies the gradation based on viscosity, and viscosity we know it is measured in terms of poise, and here 30 implies that the value of viscosity, it will be 100 plus minus 20 into 30, and the units will be poise. With this implies that the minimum value of viscosity will be 100 minus 20 into 30, and the maximum value will be 100 plus 20 into 30. So this is equal to 18 to 30, that is 2400 poise, and this is 120 into 30, that is 3600 poise. So the correct answer would be B option. The next question is, the Le-Chatelier apparatus is used to determine compressive strength, fineness, setting time or soundness of cement. So it is a direct fact based question. To measure the soundness of cement, we use either Le-Chatelier's test or autoclave test. So the correct answer would be D option, that is soundness of cement. The next question is, a waste activated sludge, that is WAS, is to be blended with green waste GW. The carbon and nitrogen contents as per kg of WS and GW on dry basis are given in the table. The ratio of WS to GW required up to 2 decimal places to achieve a blended C/N ratio of 20:1 on dry basis is. Let the mass of waste activated sludge be X and mass of green waste will be Y. Now C/N ratio is equal to 20:1. This is given to us. Now the contribution of carbon from WS will be, for each kg it is 54 gram. So if it is suppose X kg, then it will be 54x. We are neglecting the conversion of gram into kilogram. Plus if it is Y kg, then carbon will be 360. So this 360 into Y. And the amount of nitrogen divided by, if it is X, then it is 10. So 10x plus, and if it is Y, then it is 6y. Since we are dividing the values, the conversion automatically gets removed. So C/N equal to 20/1 equal to this value. So solving this, 20 into 10x, that is 200x, plus 20 into 6y, 120y equal to 54x plus 360y. It implies that 200 minus 54, that is 146x equal to 360 minus 120, 240y. Now we have to determine the ratio of WS to GW, that is X is to Y. So from here X by Y will be equal to 240 by 146. So it comes out to be 1.6438. So up to 2 decimal places our answer will be 1.64. The next question is, variation of water depth Y in a gradually varied open channel flow is given by the first order differential equation. This is the relation. Given initial condition Y at x equal to 0, 0.8 meter, the depth of flow at a downstream section at x equal to 1 from one calculation step of single step Euler method is. Now since it is a gradually varied flow. If it is a uniform flow, then the depth of flow remains constant. Here depth, here and here, all values will be same, y, y and y. But in this question, it is a gradually varied flow. So depth will not remain same, it will be changing as we are moving downstream. So suppose this is x equal to 0 and this is x equal to 1. Here it is given to us the depth at x equal to 0, that is y equal to 0.8, and here we have to find out the depth at x equal to 1. So let it be y1 and this will be this y2. Now since we have to use single step, we can say y2 will be equal to y1 plus delta y, and this delta y will be calculated from this value. So using applying the single step, we will get here delta y by delta x equal to this value, and the value of delta x in this case is x equal to 1 minus x equal to 0, that is 1 minus 0. So this is equal to 1 minus e to the power minus 10 by 3, and we are applying this dy by dx at x equal to 0. So here y is y1, that is 0.8. So that is natural log of 0.8 divided by 250 minus 45 into e to the power minus 3 natural log of 0.8. So from here delta y will be equal to this value into 1. So it comes out to be natural log of 0.8 into 10 divided by 3 to the power minus answer and 1 minus this value. So this is 1 minus 2.1039 divided by 250 minus 45 into again minus 3 into natural log of 0.8 e to the power answer into 45. So this is 1.953. So it comes out to be minus 1.1039 divided by 250 minus 45 into 1.953. That is minus 6.809 into 10 to the power minus 3. So this is 0.006809 meter. And since delta y is this much value, we have to calculate y2. So y2 will be equal to y1 plus this. So y1 is 0.8 and delta y is this value. So 0.8 minus 0.006809. So it comes out to be 0.793191 meter. So up to 3 decimal places it will be 0.793. The next question is, a rapid sand filter comprising a number of filter beds is required to produce 99 mld of potable water. Consider water loss during backwashing as 5%, rate of infiltration as 6 meter per hour, and length to width ratio of filter bed as 1.35. The width of each filter bed is kept equal to 5.2 meter. One additional filter bed is to be provided to take care of breakdown, repair and maintenance. The total number of filter beds required will be. Now the discharge required for the municipal usage is 99 mld, but 5% is lost during backwashing, so the actual water discharge will be equal to 99 plus 5% of 99. So this is equal to 1.05 into 99, that is 103.95 mld. Now it is given to us the length to width ratio is 1.35 and the width is kept as 5.2 meters. So this is 5.2 meter. Therefore length will be equal to 1.35 into 5.2. So area of each filter bed will be 5.2 into 1.35 into 5.2. So it comes out to be 36.504 meter square. So total discharge required is this much, area is this much. Now the rate of filtration, this is given to us 6 meter per hour. So it is equal to 6 meter and 1 hour is equal to 1 by 24 days. So this is equal to 24 into 6, that is 144 meter per day. So the number of filters required will be equal to the discharge, that is 103.95 into 10 to the power 3 meter cube per day. 1 mld is equal to 10 to the power 3 meter cube per day. Area of each filter, that is 36.05 meter square, 36.504 meter square, and rate of filtration 144 meter per day. So all the units are consistent. We will get number of filters, that is 103.95 by 36.504 by 144 into 10 to the power 3. It comes out to be 19.775. So numbers required is 21, and it is given to us one additional for breakdown and repair. So total number will be 20 plus 1, that is 21. So the correct answer would be C option. The next question.